Question 16 now. This is a proof question where we need to show that the left-hand side equals the right-hand side. So lots of ways to do this. I'm going to take the left-hand side and then do some algebra, hopefully end up with the right-hand side. So I've got 2m plus 1 times 2m plus 1 minus 2n minus 1 times 2n minus 1. Right, let's deal with this side first. I've got 2m times 2m is 4m squared. 2m times 1 is plus 2m times another 2m like that. 1 times 1 is plus 1. Okay, minus, I'm going to put this in brackets because it's take away all of the other ones squared, so we don't want to get confused with that. 2n times 2n is 4n squared. 2n times minus 1 is minus 2n. We've done these two. Next two is a minus another 2n. Minus 1 times minus 1 is plus 1. Okay, let's do some tidying up. 4m squared. 2m plus 2m gives me 4m. That one stays as it is. Okay, in here I've got minus 4n. Okay, now I need to deal with this sign outside over here. And everything in that bracket is going to be multiplied by that minus 1. So that minus times 4n squared gives me minus 4n squared. That original minus 4n that I had turns into a positive 4n. Minus 4n times minus 1 is plus 4n. And then minus times a plus 1 is minus 1. Okay, looking at that now, I can see that plus 1 and that minus 1 cancels out. So what am I left with here? I've got 4m squared minus 4n squared plus 4m plus 4n, like that. Okay, first thing I note is everything's a factor of 4. So let's factorize that out. We've got 4m squared minus n squared plus m plus n. Okay, good. Right, then this is like, again, noticing and spotting stuff. This bit here, m squared minus n squared, that is difference of two squares. So that I could write as two brackets, m plus n, m minus n, like that. Let's leave everything else as I had it. The 4 was still there, everything was in brackets, plus m plus n, like that. Okay, right, what can we see? We're almost there. So I've got the 4. That's sitting outside, and I've kind of got the m plus n in brackets. I've got the m plus n here. If I group that into brackets there, can you see I can treat this bracket and that bracket as factors. I can take them all out, I can factorize it. I can sit them outside the brackets. What would I end up with? 4, factorize the m plus the n out. Okay, what am I left with now once I factorized it? So let me get a different color. Taking out the m plus the n from there, what am I left with on this side? It's just m minus n. I'm just using brackets for now so you can see what I'm doing. This has been all factorized, but it's not like I've got nothing there. I would have a 1 left over like that. So let's tidy it all up. That gives me 4 m plus n, and then what am I left with in the other bracket? M minus n plus n. You can get rid of the brackets inside, and that equals the right hand side as we needed, as we wanted. Okay, let's give you a minute to kind of see what I've done. So here we multiplied. There we've cancelled the ones. There I've factorized the 4. Okay, here was difference of two squares. There I factorized the m plus the n out. Okay, and that's it. That's my proof done. Right, B says that the result in part A shows that the difference of two squares of any two odd numbers must be a multiple of 4. And is Sophia correct? Let's have a look. any two odd numbers, is she going to get two odd numbers? Well, 2m plus 1, doesn't matter what number you have, 2m plus 1 will always be odd. Okay, always, always, always odd. Because you're multiplying something by 2 and you're adding it once. It's always going to be odd. And then let's have a look at the other number. It's 2n minus 1. So 2n minus 1, same principle. Multiply something by 2. I'm going to take away 1. Is always going to be odd. So is she correct? Yes, she is. As we will always be subtracting odd numbers. Subtracting not just odd numbers, it's the subtracting the square of odd numbers.